We are here for Mike Howsden with Zen of Quality, how PBS measures quality of service for digital viewers. And one quick note before we get started, there's a survey going around for the closed captioning. We ran out of copies up here, but keep an eye out. They're going to distribute cards with information on how to complete it online, and we would really appreciate it if everyone could fill that out before they leave. And with that, I will hand it over to Mike.
Hello, everyone. Can you hear me? Yeah. Hello, everyone. Welcome. I'm here to talk to you today about our video quality of service system at PBS Digital. Who am I? My name's Mike Howsden. I'm currently the Director of DevOps for PBS Digital. I build operational tools to make things run faster, better, and cheaper, hopefully. I coordinate with development to make sure we spend our time optimizing in the best places. On a more personal note, I've been using Python wherever I can for about a decade, and I love the community. It's really an honor to be speaking in front of you today. PBS Digital. We do web, over-the-top, and mobile application development for PBS. For our purposes here, we serve videos and lists of videos to as many platforms as possible. Disclaimer, PBS does not endorse any product or service mentioned, and opinions expressed here are my own. In other words, anything I say here that you interpret positively should be attributed to PBS, and anything you may disagree with or find offensive should be attributed to me. Why do we need this? Why do we need a video quality of service system? Well, it's because PBS runs its own video streaming system. We run our own streaming system because we think that it should be one of our core competencies. It's hard to know what is at fault when a user has had a bad streaming experience. We need insight into user experiences around the country, end user bandwidth, and ISP service degradation in relation to our CDNs. The complaints we get from users are inherently anecdotal and generally don't come with enough data to make a good diagnosis. But why do we need this? Well, it's because our users end up looking at a screen like this far too frequently, and we want our users to have good experiences because we know a bad experience can lead to users leaving our products in favor of one of the many other options available at their fingertips. This is what it looks like when our users are having a bad experience on our video portal. We care about our users. This product got started a few years ago when our VP stopped by with complaints about users experiencing buffering. The VP got emailed by, say, the director of one of our local PBS stations, and he wanted to know why that station had a bad experience. A few years ago, we couldn't tell you if the problems were isolated to that particular user or related to more general internet or local network problems. We hacked something together quickly to make sure nothing too significant was broken, but it was very raw. Around the same time, one of our engineers determined that his ISP was having trouble streaming from our CDN and that it was localized to his ISP, since the same problem couldn't be seen via proxy. Problems with CDNs can be related to edge node issues, peering agreements, or simple routing issues. Things that are out of our control, but we need to know about. After encountering this problem, we looked for a quick out-of-the-box solution to solve it. Unfortunately, vendors providing this type of service are very expensive, on the order of $50,000 a month minimum for anything near our level of streaming. So that's a lot of development time. Integrations have a non-trivial development cost. Vendors often take a long time to integrate with a new player, and we're frequently early partners on new platforms, so that integration time can be critical. We want an independent way to evaluate our vendors' players. Some vendors who sell players also provide analytics, but I don't want to rely on them to know how well their player is doing. There are no good open source solutions. So far, we've been open sourcing each component in this product, and we plan to continue as we improve it. If you happen to know of a different open source solution to this problem, please let me know after the talk. Okay, before I get into the details of implementation and all that, I want to show you the output we end up with so you can get a better feel for what we're after. This is Tableau. It's an enterprise data visualization product that can connect to a variety of data sources. Some of the typical things we want to look at are shown here on this chart. If you look at the top left, you can see videos with the highest number of buffering events. This can often tell us if we have a bad encoding. If you look at the bottom left, you can see quantity and quality of streams around the country. This is over a month, which is why everything looks good. Over a day would usually have more variety of color there. Top right shows us key metrics we're following. That red line dip was a lower number of incomplete streams, likely as a result of a player improvement. So basically, we can see our players improving over time. Buffer events by player is middle right. It shows us which players are performing the best. Buffer events by ISP, bottom right, shows us the horrors of duopoly. So in a business sense, this slide is the essence of what we're after. And I'll now go on to describe how we get there. Agora overview. The Agora is the code name for this project, so if I refer to it as Agora, just so you know. This framework attempts to follow best practices, but is specifically tuned to video quality of service. Similar frameworks exist for other business applications. The goal is to be modular and clearly define interfaces. This is one of the projects at PBS Digital that we consider big data. So we have, like, on a day, I just picked a random day, but probably a typical day in spring. We had about 70 million events, and which turns into 7 million stream profiles. So what's the technical challenge here? Well, for each video view, a player fires events like media started, buffering start stop, media paused, etc. These events are often spread over multiple hours. These events need to be collected to represent a stream. Then they need to be interpreted to create a stream profile. These profiles need to be analyzed and summarized to answer our business questions. So to speak more specifically, let's take the case of a user experiencing buffering that we mentioned earlier. In that case, we gather the media buffering start and end events, determine the time delta between them, and add those, and then calculate a ratio in relation to time watched. I hope that made sense. It's important to note that these problems could apply to any video streaming system. So now I'm gonna go through the 6 stages that we use to do this. Stage 1 is player instrumentation. We started with the JW Player plugin, which is our desktop player. We have a list of events. We ask each player to asynchronously fire to our service. The list updates as we find new metrics we want to track. OTT, Android, desktop so far have all been able to asynchronously fire the same events to our logging service. The events we're looking for from each player are listed in the README of the Agora Proc repository, which I'll talk about towards the end. Most of this stuff is open source, so I'll give you guys some links and stuff. Stage 2 is data collection. We have this service called Goonhilly. It's our logging service. It's an HTTP collector written in Flask. It writes to a standardized log file. We could use a more fancy system like AWS Kinesis here, but we haven't actually found a need for that. Stage 3 is data distillation. We use a Hadoop-based MapReduce and on AWS EMR and the Python library Mr. Job. The data is received nightly in compressed log format, and output is written to JSON, both in S3. Those little smiley faces represent the things that are open source that other people can take a look at later. Stage 4 is data load. So the JSON that we create from the JSON that's been created from the earlier process is then prepared to insert into a Postgres database. There are challenges with Unicode, quotes, and other inconsistencies that mean we have to sanitize input. We use Postgres table inheritance for partitioning by date and audience. Agora DB load is the piece that does the table partitioning and triggers and all that sort of stuff. It isn't open right now, but it will be open source soon. Stage 5 is data analysis, summary tables, and extracts. Even the reduced data that we get is too much. 7 million rows in a table gets pretty unwieldy. So even if I'm partitioning by date, if I still have a 7 million row table, you can imagine queries get pretty slow, even with indexes and things like that. So we run additional jobs to look for specific patterns. We continue to want each stream to be represented by a single row in a table for ease of use and finding new patterns. We've partitioned this table between general audience and kids data. Our kids data is, we have a lot more quantity of kids data. So our general audience data is small enough we can look at the data directly, but our kids data really can't be looked at in any reasonable time frame without looking at summaries. The last piece is the data visualization, and so kind of represented by the Tableau screenshot that I showed earlier in the presentation. For this, you can roll your own. You could use HiCharts, Google Charts, D3.js, Datadog, or you can use a system that's off the shelf like Tableau. We've used both approaches depending on what we're trying to do. When you're making a decision about this sort of thing, you need to carefully weigh the return on investment, the flexibility for experimentation, and tools for the skills of product managers. So, because sometimes we just don't know exactly what we're looking for, and so the more people that can just play with the data, the more you can start to see correlations, and then those correlations start to feed back into the system and change which events you track and things like that. There's also a question of how you want to expose the visualizations and whether they're interactive or baked. Like a dashboard might be more baked, and interactive might just allow different stakeholders to drill down into metrics. Once again, there's a little smiley face for open source stuff. Okay, future enhancements. So this was our first attempt to get something off the ground to solve this problem, and it took a significant amount of time, and we just decided to do it with batch processing. So we do everything just nightly. So all these events are processed overnight, and we get all this data like the next day something happens. So if we release a new player, we wouldn't necessarily know that the new player is broken until the next day. If we can switch like to real time or something like that, then we should be able to release like a player early in the morning, and then by afternoon know that that player was good or bad and do a rollback before the evening. And the evening would probably be like our biggest traffic time. So there's a lot of value in real time just from an operational perspective. So we've been looking at Spark and Storm. So all the Spark and Storm talks that everybody's doing have been awesome. I got to play the most with Spark. It seemed like I needed Spark streaming capabilities, and it seemed like some of the stuff might be a little bit immature. I definitely kept running into errors that were like not very descriptive and hard to debug. But that still seems to be one of those. Still seems like the way that we're going to go in our next iteration of this system. We also want to have dashboard-style live visualizations for operational monitoring. We'd like to just be able to see how many streams are buffering over time in general and things like that, just as they occur, and correlate that stuff with our other operational metrics. So that's one of the main reasons we're considering Datadog. So most of our operational metrics are being stored in Datadog. If we can get this system kicking into Datadog, that would be really useful. We also want to do alerts and automated decisioning. So like if, for instance, New York's having a real hard time with one of our CDNs and we need to switch to a different CDN, we'd like to be able to do that. We currently use a system called Sidexis that supposedly does kind of load balancing for CDNs. It does like it checks how long like a packet takes to get to a particular destination, and then it just kind of keeps a table, and it should theoretically balance that for us already, but we've run into like, I don't know, it's hard to know whether that's really working as well as we want, and there's other things that we could watch that we'd like to decision off of as well. The most important thing is that we continue to have flexibility for our changing business needs. So just keeping so even though we need to do these like table summaries and things like this off this data, we really want to have one row per stream so that if somebody wants to dig that deep into it, that they can get that level of data. This is the list of the code and resources. So this will be available whenever these slides come up online. Let's see. I guess that's about it. So we can open the floor for questions.
Hello. Oh.
Hi.
Hi. Could you go back just one slide to the resources? Yeah, thanks.
Sure.
Thanks for your presentation. I'm doing a project right now where I need to be able to measure the number of minutes that were watched over a whole bunch of different videos in a certain time period. Like say, given a month, these videos were watched this many minutes, these videos were watched this many minutes. Is that something that the Agora tool that you built can generate a report like that?
I don't know if we've got that like wired into it, but yeah, that's the framework. So yeah, that it should be able to do that, especially as it progresses. It should be able to answer that type of question. So it's kind of hard sometimes to tell when a video ends because you don't always get like media ended event depending on how somebody closes out of that session. So and I don't know if anybody's familiar with the on-unload event or whatever in browsers and like browser support for the on-unload event. So if I have like a media ended event, it's fine. Then I can say, okay, media started, media ended, and then I subtract like buffering time or I subtract ad time or whatever, right? And then I get basically watch time. But if I don't actually get that media ended event, then I kind of have to guess, And so unless you're going to want to do like polling all the time, you're not necessarily going to see the media ended, when that media ended thing happens. And I feel like introducing polling is kind of like, I feel like I'm going to run into the observer effect, if that makes sense. You know what I mean? I just don't want to add that to my event system. It's just too chatty. I just also feel like it's rude.
Yeah. No, polling is very messy. Is that a function of the player though? Like maybe the JW player could talk to your backend and
depending on the play. So yeah, the player could possibly tell you that, and that depends on the player. So we have a number of different players that we're using. Whoever built our Roku player is totally different than the who built the Apple TV implementation, which is totally different than the desktop implementation.
Okay, thanks.
Hi, thanks for the talk. So I actually have a few questions, so hopefully maybe I can find you afterwards.
It's great. I think I have a little bit of extra time, so.
All right. So my first question is, one for now is, what are maybe you can share some of like the top observations you made once looking at quality of service, like were there some obvious things or like low-hanging fruit that you found across your different platforms and stuff like that?
I don't know about low-hanging fruit. I mean, I think we were able to tell certain characteristics about the players really fast. Like so before we had this system, we couldn't really tell that, one of our players on average had like 6% of whatever metric, whereas the other two players had closer to like 3%. So we knew that player maybe they had a bad HLS implementation or something like that. And so we were being able to see like when a player gets substantially better, that was like a huge win for us. And then just because before we kind of didn't have enough insight into that, and then being able to see like these areas of the country, like a particular ISP, like obviously has issues with this CDN. Like, so those two things are the biggest things. So player quality and relationship between like ISP and CDN. That was the big thing that came out of all this for us.
Thanks.
Hey Mike, have you been able to hook this in and use it on anything on the backside, like on the Amazon side? Have you been able to sort of use it to say, hey, the logic that I'm using to scale up and scale down is off or anything like that?
No, I mean, I don't think so. I haven't used it for scaling. You mean to use it for a scale trigger or something like that?
Yeah, well, it sounds like
event?
This is more based on browser data. How are you sort of doing the same thing on the provider side as far as realizing you need more endpoints to send out, or is this completely unrelated?
I mean, everything's delivered via. Hopefully, this is the right question that you're asking, but everything's being delivered via the CDN, right? So I'm not really controlling like what the edges are doing, because I'm just sending HTTP via a CDN. So and then from there, all I'm doing is just seeing how well that delivery's going. But I haven't really, I haven't really tried to tune beyond that. So
for collecting the event firings that are coming into your Flask app on an instance, what made you decide to use a Flask app to accept that versus using like query parameters on objects in your CDN and then processing those logs asynchronously?
I think, I mean, more than anything is that service was kind of like up and we were firing events to it. And it wasn't really necessarily being used for this, but then somebody started using it a little bit for this when we were first looking at it, and then we just kept going with it, and it scales pretty well, and it's not very HTTP respectful actually, this service, but it seemed to work really well for our needs. I mean, it's like 4 servers or something, and it can accept a lot of events. So yeah, we could do similar things from the CDN logs. We also have multiple CDNs. So we would be aggregating from both of them, and then we'd be looking for these particular things coming from the CDN. So I guess that kind of like cuts all that out of the loop. But there's not really an obvious advantage to one way or the other. There's a lot of different ways to skin the cat, and the system's built modularly so that if you do try to skin it in a different way, you should be able to drop out components. And as it gets, more. This is really in an early stage, so as it becomes more like production worthy, we're like in the process of elevating it to like a legitimate project, even though we've been using it for various things. But once it gets to that state, it should be much better.
Thanks.
Hi there, Mike McFadden, Radio Free Asia. Thank you very much for that very informative talk. My question is specifically on adaptive streaming, and have you come across or possibly even implemented anything that can send an event when an adaptive stream changes, like somebody moves into a bad cell service and all of a sudden they're getting a low bit rate video? Have you looked into that? Or?
Yes, actually this system looks for manual and auto bitrate change events. and we collect those over time. Those are one of the metrics that we track through the system right now.
Excellent. Thank
so,
you.
It's not going to tell me for sure that I went to those networks, but since it also collects like ISP data, like we use MaxMind to kind of figure out ISP data, we could probably do that correlation and have something about mobile transitioning, but we haven't really done. That isn't completely wired up, but the bitrate changes are.
Thank you very much.
Okay, if there are no further questions, I guess we're finished up here. Thanks everyone for coming out. Thanks to Mike for a great presentation, and everyone enjoy the rest of your afternoon.